I'm French, like most of my other colleagues also from Hexagon today. And I would like to start very quickly in presenting you who is Cradle CFD. So Cradle CFD is a Japanese software. We have been founded 38 years ago. And we have a Catalan mindset. That means our goal is really to provide a pragmatic tool to deliver you productivity in going faster and finding solutions. Because we have been acquired 6 years ago by Hexagon, in fact, we have started to develop some multi-physics approach, because for us it's very important to better capture the reality. There is another point that is not so famous, I would say, when we are speaking about CFD, it's about visualization. In fact, Cradle CFD is a all-in-one product, and you have a post-processing which is very powerful. And since 2 years, we are trying to develop some new capabilities like augmented reality, virtual reality. So it's very important now to have a better insight and a little to, I would say, go in the trend of the metaverse somehow. But just let me have a short presentation also about our product. So we have 3 products. The 2 main products are SCFlow and SCStream, and you would like to know a little more what's the difference between, because if you are looking at the physics that we are answering, 90% of the physics are answered by both. In fact, it's very simple. The SCFlow is based on unstructured mesh, and the SCStream is more on Cartesian grid, which is very powerful for electronics as the iMac is using it, or for the environment. We have also a little tool which is called Pickles, so don't ask me why the name, but it exists. And the added value of this tool is to provide you some real-time answer when you want to design PCB and when you want, for example, to check the positioning of some component on a PCB when you are speaking, for example, with your customer. So you have a PCB, you have different MOSFET, whatever on the PCB, and you want to see what are how does it impact the temperature. But let me show you a little, I would say in a glance, in 5 minutes, what will be the topic of today. So you might look at the productivity when you might search for productivity with a tool. And then you are looking at the efficiency of this tool and about the latest enhancement. But productivity is also about how are you using the tool, and that's completely different. And this is why it's very important also to speak about multi-physics, well, we had a presentation about machine learning, and of course about the AR visualization, because it's really helpful currently. So let's start with the efficiency. Yes, okay, the video is arriving, so I was just checking this, I'm sorry. In fact, before solving anything, you have to import the CAD and to mesh it. And if we are speaking to some engineer, and when we ask them, how long does it take for you just to import the CAD, to clean the CAD, to grid it, to mesh it, and to get the result? And most of the time is in fact concentrated on the CAD preparation and the mesh preparation, and it's useless somehow. It's not where is the added value of an engineer. Where you want to go is to have a very fast solving analysis. You don't want to spend your time just in cleaning the CAD. For you, it's no added value. So Cradle is proposing you two solutions, so with SCFlow and SCStream. And in fact, the concept is really to not unlock any clean CAD. We don't need this. And this is either you are looking for a model with a high accuracy and boundary condition, and this is where you can go with where we will propose you to utilize SCFlow, or maybe you have to handle a very large model, and for this it's better to use a Cartesian grid with SCStream. So, for instance, you can do the mesh and the grid in 5 minutes. For 41 million elements with SCStream. So it's really powerful. But when we are speaking about solving, of course, the efficiency is a key thing, but it's also an ongoing process, I would say. So as an example, so SCFlow has been developed in collaboration with the NIA. So the NIA is the incubator of the NASA. So we were very proud, of course, to have, I would say, the latest technology inside of solver. But the point is that we have to check that year after years we are able to improve also the efficiency of our solver. And this is exactly what we were able to demonstrate in this test, which is a very public one. You might know the Aerodynamic Prediction Challenge. It's presented by the NASA. And not only we were able to do it faster than the previous year, but we were also able to capture very well the reality and to be well placed on the market compared to the competitor. But okay, so now you have a Ferrari, you have the key of the Ferrari in your hand, except that you are limited to the parking lot of a supermarket. So you're not going to go very fast. And this is exactly the same if you are in Monza with a 2 horsepower. The same, not going very fast. So what I want to tell you is that here there is a real need to have a co-design between the hardware and the software. Because it doesn't make sense to utilize HPC with more than 1,000 core for a very small model. Doesn't make sense. So what we are proposing to you is, it's very important also because we are just a software company. We are not providing you your own HPC or your own environment. And this is very important that to be sure that our product will be fast enough on any kind of HPC architecture you will utilize it in the future. So of course, Intel, AMD are very famous, but we test it as well. But the latest one, which is the ARM architecture. And because we are Japanese, of course, we had the chance to test our software in Fugaku, which is the second biggest supercomputer in the world. As you can see, we had a very good scalability, and we were even able to run some simulation with 260,000 cores with SSTream, or 192,000 cores with STFlow. But yes, I would say pick some enhancement because we don't have time. I would say CFD, it's a huge industry and a huge physics. So we had already automatic adaptive mesh, but in steady state, and we just added the transient, and that's helped to better capture the vortex. Because in fact, if you want to do it, normally the problem is that you end up with a very large model and the computation time is very long as well. So that's why it's very important to have these new capabilities now. We have added as well the hypersonic solver. So the hypersonic solver is an extension of the density-based solver, and you know that above Mach 5, in fact, the ideal gas law is no more relevant. So you have to integrate thermochemical non-equilibrium law, which has been done, but hypersonic is something, but maybe you want also to add some other topics like the motion, like the CHT, and our hypersonic solver is supporting those functions. So Cradle CFD is also integrating a DEM feature, but up to now we had only spherical particle, and since the latest release, we are able to provide some cluster, but also what is always important in terms of productivity is to provide a dynamic model, so you are able to do some simulation, I would say locally, and then you are reducing again the computation time. Well, those things are also quite important when you want to reduce the time computation. It's about converting a real involved to a Lagrangian particle, because we had already both things, but we didn't have the conversion from one to another one. And when you want to analyze atomization of a jet, for example, this is quite helpful. But let's speak about some other method. So as I mentioned at the very beginning, we have a platform, a co-sim simulation platform, which enables our product to run some double coupling simulation. So I'm not speaking about chain simulation, I'm really speaking about two-way coupling, which is a slightly different. So we are able to couple thermal simulation with structural analysis, or to even integrate some discrete element modeling with Adams. So yes, I think it's always better to have some example under the eyes. It gives you a better understanding. There is something that I like to show here, is that the fluttering of the wing, I think everyone knows that we need to be very accurate, and everyone is trying to do some very nice aeroelasticity. But there is one point that we never speak, is that it's exactly the same in the automotive industry. And for example, up to now, the OEMs, they are running, they are not running this simulation because it's too complex, it takes too much time, and they have to wait the car to go to the wind tunnel aerodynamics test, and then they check if the vibration of the wood is fine or not, and otherwise they have to strangle the wood, which is not very good for the fuel consumption. So this is why doing some multi-physics approach helps you to get some answer before to go to the production line. I'd like also to speak about openness, because up to now I was saying, oh great, we have a platform with, which is connecting the Hexagon product, but we have also the ability to connect with external product. Like if you want to integrate some juice losses from IMAG simulation, is also possible, and it's important, because if you are not integrated those, then the result that you will get only based on CFD won't be accurate. It's exactly the same when you want to do some thermal runnery. It's also important to cooperate with 1D, and as we have FMU, there is no problem to handle such things. I will finish with visualization, and I think I will be on time. So I'm going to show you an example, because sometimes a movie is better explaining than word. So here it has been done in a clean room of one of our customers. So this customer is providing Cradle, is providing, of course, HVAC simulation, and it's helped to have a better insight about the airflow, for example, about the air isosurface. You can check also into the room if there are any space which are not renewed correctly. Well, you know that clean room is very important to be checked in terms of contamination, and I think with after the pandemic now, everyone is more careful about this type of things. So the yellow stuff is, I would say, the isosurface, where the air is not renewed. You can also integrate, for example, some thermal index, because as you know, it's very important to have some 3D insight. And so, yeah. So, just a last slide, Melissa, just to explain how we are able to do such things. Because we are Hexagon, and in this sense, we are very lucky, because we have all the products in our portfolio to go from a 3D scanning by using a Leica scanner to take the cloud point, and then after we are able to, as you can see, we can rebuild the 3D CAD, and we can export in IFC file, and from the IFC file, we go directly inside Cradle, because we can import the IFC file. And based on that, after it's very simple, it's just a 2 minutes click. That means you have a calibration point into your simulation, and you post exactly the same calibration inside in the reality. And automatically, you can superpose the simulation in the real environment. The application is available on Apple, so you need an Apple iPad 12 Pro, or at least iPhone 12 Pro, and it's just yes, available for anyone who wants to do some AR simulation. It's very one click on the right, so I think it's pretty funny to do it and to check it. I'd like also to remember that we are currently running a CFD tech series, so for anyone who is interested in better knowing about, for example, machine learning, or yes, the CAD, so how we are handling non-clean CAD, then it's available also. So thank you very much. I hope I didn't bother you too much. Thank you.